Okay, so we've been looking at different ways to represent data, graphically speaking, and we looked at a lot of different things. The frequency table, we looked at pie charts and things like that. There's a couple of little documents that I'm going to upload into the learning management system so that everybody can see them. For instance, one of them, speaking of pie charts, is a document that looks something like this. And what it does is it gives you a circle, but it's broken down. If you look inside of here, there are 10 little units, little areas in here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 10. There are 100 if you count each little section in here. There are 100 sections. So this can actually be considered a percentage circle. Okay, it's broken into 100, or each little section is a percentage. Okay, and so if you wanted to represent something that was like, say, 22%, you could do this entire section, that's 10%, this entire section is 10%, and then 2 more would be 22, and you could just draw an extra line there and shade that. It just allows you to be a little more accurate with the way that your pie charts look, because as we've discussed last time, pie charts are a little bit difficult because they're in percentages. So first you have to find the percentage, and then you have to be able to figure out what portion of the circle that is. Okay, so I'm going to load a couple of documents into the document section. But other than that, I want to talk about these two graphs. One is stem and leaf plot. And what a stem and leaf plot is it's a very specific graph, and I call them more modern. That's because the other ones have been around for years and years and years. But these came around in, say, the 70s and the 80s, so 1970, 1980, that area. So they're relatively old by today's standards, but when you consider a bar chart, for instance, which is hundreds of years old, they're not that old. So that's why I call them more modern. Anyway, what does a stem and leaf plot do? Well, say I have a lot of data points. So say these are my test scores. Okay, and I'm going to write a bunch of them out. And what I'm going to do, last time I mentioned binning our data. So I'm going to, the stem and leaf plot, what it does for us, it's a nice way of binning our data. So it bins the data for us. Okay. And because I'm dealing with test scores, I'm going to separate mine by tens. Okay. If I had, I don't know, people's weight, and the smallest person I was weighing was 110 pounds, I might separate them by 100 pounds, or the bins might be in groups of hundreds, or we might do 100, 150, 200, 250. So we might group them in different ways depending on what kind of data we have. But because I'm doing test scores, I'm going to group mine by tens, because that makes sense for us, because I'm going to have a 51, a 57, a 58. Well, all of those are 50s, so they're going to be in the same group or the same bin. Okay, I'm not going to have any 60s. I'm going to have a 73, a 73, a 77, an 81, another 81, and an 82, an 83, an 85, an 85, an 86, and an 87. And then I'm going to have an 88, an 89, an 89, 3 90s, 3 91s, a 93, a 93, a 97, and a 98. Okay, so when I say I'm going to group these, it might help you if you kind of just drew a line. You could do different colored lines or whatever. You could circle them. Mine goes beyond one line, so I'm going to just underline different colors basically to help me keep them all straight, and here are all my 90s. Okay, so I'm going to bin them by the tens position, so there's going to be some 5s and some 7s and some 8s and some 9s. So what a stem and leaf does is it splits the data according to whatever we tell it. So like I said, in this case, my stem is going to be by the tens position. And my leaf, okay, And I put up here, AKA stem plot. It's a stem and leaf plot. The leaf in this case is going to be the ones. If I was doing hundreds here, then the leaf would probably be tens position or something like that. But it just doesn't make that any sense. Let me actually go ahead and let me add in a data point. Well, I'll talk about it in a second. Okay, so looking at the tens here, we always start in the bottom at the lowest one. Well, there could be a 0, right? No tens. Like if I had a student who made an 8 on their exam, I could have a 0, 8, right? The tens position would be a 0. The ones position or the leaf would be an 8. So I could have that, but I don't. The lowest I have is a 50. So what I'm going to do is I'm going to use my little lightning bolt that we used whenever we were doing bar graphs and line charts and stuff like that. And that's just going to represent to anybody who's looking at my stem and leaf plot that I know I'm skipping. Okay, I'm supposed to be going by tens, but I don't have any zeros. I don't have anything that was in the teens. I don't have anything that was in the 20s. No 30s, no 40s. So I don't want to write those down. Okay, I don't want to put them in there and take up a lot of space. You can, and if you did, you would put a 0, but you wouldn't put anything in the leaf, right? Because I don't have anything in that position. So instead of messing with that, I'm just going to skip to the 5s. So I do have some 50s. So my stem in this case is the tens positions, what I said. So I'm going to split my data along the stem and leaf. So the stem is the 5, and the leaf is going to be whatever the ones position is. So there's going to be a 1 over here. So that whenever I look at this data point, I can say, oh, that was originally a 51. Okay. And then the next position over here, the next data point that I have is a 57, right? So I'm going to do a similar thing. I'm going to split it up. The 5 is already represented here in the stems position, 50. And then I need to put the 7 over here in the leaves position, so I'm just going to write a 7. Okay. And what this does is I'm able to see the original data point, the raw data, and I can put it all back together. So it rearranges stuff, but I can see, oh, that was a 51, that was a 57. The next one is a 58, right? If I split it right along between the tens position and the ones position. Okay, so then now that I'm in here, I can't skip. Okay, you can only skip at the beginning, remember? So I need to put 60s, but we see that we don't have anything in the 60s position. So you do not, what you don't want to do is you do not want to put a 0 there. Why not? Because if you put a 0 there, it tells me that I have a data point that is a 60, a 60, and I don't have any of those, right? So I don't want to accidentally let somebody think, oh, we had a 60. So instead, I'll either leave it blank or I'll put a little dash out there to let you know there really aren't any 60s. Okay, next is 70s. So I do have some of those, so I'm going to put a 7 over here. And real quickly, think to yourself, what's this leaf part going to look like? What am I going to have there? So let's see. We have a 73 and a 73. So I have two 73s. So my question is, I know I need to put a 3 here. Is it okay for me to just put 1 3? That's my question. And hopefully you're saying, well, no, that's not fair, because if this is Susie Q's grade and this is Mary Lou's grade, well, I don't want to just put 1 73. I need to represent the fact that both of them made a 73, right? So again, we're coming back to that idea of whenever I'm representing my data, I need to make sure I represent every data point that I have. So both of those 73s need to be in there. So you can't just go, oh, I've got a 73, move on to the 77. So hopefully for your 70s, you've got a 7 over here for the stems position, and then you've got a 3, and a 7. And like I said, when you're finished with that, you can come back and you can look at it and you go, oh, we had 3 70s. There was a 73, a 73, and a 77. So you can put that back together and get your data. So I'm going to give you just a second. If you need more time, pause the video. Come back to it whenever you're finished with this, whatever. But I want you to do the 80s. So I'm going to give just a second, and then I'm going to do it. Okay, so what I see here is an 81 and an 81. And again, we need to represent both of those. So I've got a 1 and a 1. an 82, and an 83. And then again we have two 85s here, so 85 and 85. I'm going to put two 5s. And then hopefully right here you put a 6, a 7, an 8, a 9, and another 9. 6, 7, 8, and we had two 89s. And you can check yourself real quickly. You can say, look, I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 80s there. So make sure I have 11 stems, right? So here's my 80s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And hopefully I wrote them down correctly, right? All right, and then we're almost done with this group of data. So I have to deal with the 90s. So looking at that, do it real quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hopefully when you've done your 90s, and again, pause the video if you need to, you should have 10 stems, or 10 leaves over there to go with your stem that's a 90. All right, so looking at it, I've got 3 zeros, 3 1s, 2 3s, sorry, a 7 and an 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I like to put commas in between my data points here just so that we can keep them straight. I know that a lot of books don't. They just have a long list there. And that's fine as long as you only have single digits in your leaf area. But if you don't, if you end up having stuff that has, like if this was hundreds and then I had the people's weights, 112 pounds. Then I'd have a 12 over here for one of my leaves, right? So I wouldn't want people to get confused. Is that a 12 or is it a 1 and a 2? Is it 101 pounds and 102 pounds, or is it one person who's at 112? So I just like to put commas in between my points. That way it's always very clear how many data points I have and separates them for me. All right, so here's the thing that I started to say earlier. What if I had one really great student and they made 103? So I had one more data point, which was 103. What's the tens position in this? If I was to split it by the tens position, between the tens and the ones, just like I did the rest of them, I would split it right here, wouldn't I? Okay, so then what would the tens position be for the stem? It would be everything on the left-hand side of that split, right? So basically, instead of here I had single digits, 9, 8, 7, and so on, I would have a 2-digit stem here. This would be the case where my tens position is 10. Well, think about that. What's the 10 times 10? Well, that's 100, right? So that's okay. The case where my tens position is actually a 10, which actually means I have to move over to the 100 position, right? Which is what this person did. They scored above 100. And then what's the ones position? It would be a 3, right? So I would have one grade there that was 10 tens or 100 and 3. And if there was 105 out there, then I just put a comma 5 and keep on going. So you could have something like that. They don't all have to be single digits. So I don't want you to think, oh, it's always this way, because it's not always that way. All right, so what we're going to do is we're actually going to hold on to the stem and leaf plot right here, because we're going to come back whenever we get into the next big section of material, and we're going to work with it and do some stuff. So I'm not going to take this very far. It'll be on a video, and in 1 or 2 videos from now you'll start seeing this again. So keep this data handy. That's the basis of the stem and leaf plot, and I think that everybody can probably, it's usually pretty easy to see. And like I said, some of the books call it a stem plot instead of stem and leaf, and that's okay. All right, so the second type of graph that I wanted to talk to you about, that's the more modern graph, is called a box and whiskers plot. Okay, and of course in modern days, for whatever reason, we have to like shorten everything and abbreviate them and all that. So nowadays, sometimes in some books, you'll see it called a box plot. Okay, so you've probably seen box and whiskers plots, but you may not have ever made them. We use box and whiskers plots a lot for educational data, and if you want to talk about somebody took this this standardized exam and they're in the 98th percentile and things like that, we use a box and whiskers plot a lot for that. So you might have seen them, but the weird thing today is we're going to learn to create them, and a lot of people don't know how to create them. So we're going to take a little more time and spend that on the box and whiskers plot. And one of the other things I'm going to upload into your learning management system is this page, which was designed for teachers of grades 6 through 8, but it gives kind of a step-by-step breakdown of how you would make a box and whiskers plot using this data set up here, which is a pretty small data set. So I'm going to load that up. I'm not going to use it right now. I just want you to know that it's going to be available to you. So if what I go through right here, you're like, what in the world is she talking about? Then you still have the ability to go back and look at some of your stuff and go from there. All right, I need to find my data set. I'm sorry. All right, so I am going to also upload, while I'm thinking about it, a data set that shows you, it's actually 2 data sets. It is home run numbers for Hank Aaron and for Babe Ruth, and I'm going to use that now. And then what we're going to talk about is, and I don't have that data set with me. I may have to pause my video. Let's see if I can do that. Hold on. Nope, that's not doing it. All right, so I think I'm going to have to start a second video once I have my data set. So if you'll, let me look real quickly one more time. I hate to do this. Bear with me and I'll start another video when I get back.